Hello everybody, it's Ben Hackman here again. I'm going to introduce another logic gate for you. Today the logic gate will be the NOT gate. Now this is a fairly simple gate. Only one input and one output. So what happens with this gate is it will invert any signal it has applied on it. For example, it's a low applied to the input, you will get a high output. If a high is applied to the input, you will get a low output. Now the Boolean representation of this is a not sign above it. And the Karnaugh map of this, put your A not, B high. When A is low, you get an output there. When A is high, you get no output. Whoops. Now, NOT gates are used quite regularly. Normally, you don't even represent it with the symbol. You just attach it to other gates. For example, let's go to our AND gate. Now, if I were to add my NOT gate to this, I would just draw a circle here rather than draw the entire gate. Now what the AND gate will do when applied into a full another gate, so let's say this is the NOT output and this is now the NOT output, it inverts all the expected outputs. And the Boolean algebras will all get lines above them. This should become a 1 and this should become a 0. So essentially what the NOT gate does is invert whatever the expected output would be from that logic gate. So for example, the AND gate, where you'd only have a high when both A and B are high, it's now only a low when A and B are high. If we take a look at one of the other gates, for example our OR gate, and we attach a NOT gate to it by applying a circle there, and this becomes F circle, or output circle, and this is our NOT output. When we apply a low to A and B, we would now get a high input, and anything else would be a low input. Once again, we could represent the Boolean algebra of this now as we'd call a NOR gate by knotting them. We would draw a line over top. Now, our OR gate, or exclusive OR gate, when knotted, again, we just draw the symbol there. Instead of drawing the entire gate, this would become our output NOT. And again, this will invert all the outputs of the normal exclusive OR gate. And again, our Boolean algebra to represent a NOT gate at the end, it's done with a line. And that's more or less what the NOT gate will do for you.